Hello everyone, so I am Marjorie Payet and I am your teacher for today's subject. So our discussion for today is finite and infinite set. So when we say finite set is a set where there exists a projection or one-to-one correspondence. So when we say one-to-one correspondence, it is a unique elements of that set, no repetition of elements, okay, between its elements and a set of the form. So the finite set can be written as a form of 1 2 3 until n. For some natural number n, that means you can count the elements and eventually stop, okay. That's finite set. In other words, finite set is the set that you can count all the elements there. Okay? Or we can say that a set is said to be finite if there exists a natural number n greater than or equal to 1 and a projection between x and 1, 2, 3 until n. So the number is called the cardinality of x and is denoted by the denoted by the absolute value of x. Okay? So for example, here, a set of vowels in the English alphabet. So when we see the set of vowels, what are they? So they are A, E, E, O, and U, right? So there are 5 elements of that set, which is 5 is the cardinality of that set, right? So can we count the element? Yes, there are 5. We can just count the elements, which is 5. So that's finite set. We can count the elements of that set. Another example is set of whole numbers less than 10. Okay, whole numbers. So in other hand, negative is not included because whole numbers. Okay? So less than 10, what are they? What are they? Okay, 9, 8, or 0, 1, 2, 3 until 9. So that's whole numbers less than 10. So there are how many elements? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 elements, right? So with that, we can count. We can just count the elements of that set. So that's a finite set. Okay, clear? Another example is the set of the side of a triangle. Or we can write that one S. How many sides are there in a triangle? Okay, there are 3 sides of a triangle. So we can write that S, set of S is equal to 1, 2, and 3, right? So 1, 2, and 3, so there are 3 elements, right? So in other hand, that is finite set because we can count the elements of that set. Okay, clear? Makes sense. Okay, another is infinite set. Okay, another hand, infinite set is opposite to finite set. So if the finite set is we can count all the elements, the infinite set is we cannot count the elements, right? Clear? Okay. So, in other words, no matter how long you can count, you'll never finish listing its elements. So that's infinite set. Or a set is infinite if it can be placed in one-to-one correspondence with proper subset itself. So when we say, again, one-to-one correspondence, there is a unique element there, right? So unique means no repetition of elements. Okay? We can say set A is equal to 1, 2, 2, and 3. So we can say that is a one-to-one correspondence. Or we can say that it is a finite if we use the notation of absolute value of x is equal to positive infinity. Okay, that's how we express the infinite set. Okay, for example here, a set of positive integers divisible by 3. So can we list all the numbers that is divisible by 3? Okay, no, we can't list them all. We can't. Since there's 3, 6, 9, 12 until infinity. Okay, so that's infinite set, right? Another example is set of numbers multiple by 10. So 10, 20 until million, billion, trillion, or we can't list them all. So that is infinite set. Okay? Another is set of even numbers. Okay? Also set of even numbers is we cannot list them all. Okay? So that's infinite set. Is it clear? Okay, the difference between finite and infinite set is finite set is the set which can we count all the elements there. Okay? While infinite set is we cannot count or list it down, list it all the elements. Is it clear? Okay. Okay, let's try this one. Okay, if you're going to make it, then it's good. It's very good. Then, so thank you so much for listening.